Here's the magic trick that makes React so powerful. Your components don't actually render to the screen directly. When you work with plain JavaScript and manipulate the DOM, every single change triggers what's called a reflow and repaint in the browser. This is incredibly slow and expensive because the browser has to recalculate layouts, styles, and repaint elements. React solves this with an elegant solution called the virtual DOM. It's a lightweight JavaScript object representation of your actual DOM. This creates a smooth, fast user experience because React can work with this lightweight copy instead of the heavy, real DOM. Now let's break down how React actually works with this virtual DOM. It's a two-phase process that happens every time your app needs to update. First, we have the render phase, where React creates the blueprint. React calls your component functions with the current props and state, and they return a tree of React elements. This is essentially a JavaScript object snapshot of what your UI should look like at that moment. Then comes the commit phase, where React applies the changes. Here, React compares the new virtual DOM with the previous version using its diffing algorithm. It calculates the absolute minimal set of DOM operations needed and updates the actual browser DOM in one efficient batch operation. The real magic happens in React's reconciliation process, which is the secret sauce behind its performance. The diffing algorithm works by following one key rule. Elements of the same type will generate the same tree structure. This is why keys are so important for list items. Using the index as a key isn't ideal, because if items get reordered, React can't efficiently track what changed. The efficiency win here is massive because React only updates what actually changed in the DOM. Think of it like a spot the difference game with two pictures. React quickly identifies exactly which pixels changed and only updates those. Now let's see how this works when state actually changes in your app. When you call setState, React doesn't immediately update the DOM. Instead, it triggers a re-render by creating a new virtual DOM snapshot with your updated state or props. The entire reconciliation process repeats with this new data. For example, if you're updating a counter component, React will detect that only the number text node changed, while everything else remained identical. This intelligent approach prevents unnecessary full-page re-renders and is why React apps feel so responsive, even with complex UIs. So here's what you need to remember. React's rendering is a two-phase process of render and commit. The virtual DOM enables incredible performance through minimal DOM operations, and state changes efficiently trigger this entire cycle. The best way to internalize this is to practice building components and watching this pattern in action. For your next step, explore React hooks for managing state and effects. They build directly on these fundamental concepts we just covered. If you found this explanation helpful, make sure to like the video, subscribe for more deep dives into React, and let me know in the comments what topic you want to see next.